Hello everyone, welcome to tutorial video on Internet Test 1 for Introduction to Data Science. Today we will solving part A, which focused on statistical data science characteristics of feedback data. This test was conducted under the guidance of Dr. Saligram Prajapat sir at the International Institute of Professional Studies DAV Indore. Let's dive into the questions. So the question number one. The question number one asks to give three commonly used statistical measures for the categorizing depression in the student feedback data. So what is depression? So depression tells us spread out of the data is. For example, if all the students give rating close to each other, we have low depression. If rating are above and over the place, we have the high depression. There are the three most important measure are the first is standard deviation. Standard deviation, this is the most popular measure. The standard deviation, the formula is the square root of the sum of the squared difference from the mean divided by n. It tells all the average distance of each data from the mean. Higher standard deviation means more speed in the data. Now the second is the interquartile range of IQR. Means this is the calculate as Q3 minus Q1. Means it represents the middle 50% of our data. The beauty of IQR is not affected by extreme value or outlier, making it very useful and skewed distribution. Now the third is the coefficient of variation or CV. This is the calculated or standard deviation divided by mean multiplied by 100%. It's a relative measure, which means we can use it to compare varieties across different data sets, even if they are the different units or scale. Now we do go compute this efficient in large database or not. So the question is, so the answer is we can use SQL aggregate function like std-dev and variance. We can also implement parallel processing technique or apply sampling method when dealing with millions of data. In this slide we cover all about the this type of recordeds. So now moving to the question number 2. Now let's move the question number 2. The question number 2 is all about the faculty metering effectiveness rating on the scale 1 to 100. We have 17 students data which providing their rating, and the data has already but sorted in the form as 2, 13, 15, 16, 16, 19, 20, 23, 27, 30, 35, 40, 43, 44, 46, 52, and 70. So this question has multiple parts. We need to calculate first median, then second is median, first mean, median, mode, mid-range, quartiles, and create a 5 number of summary, draw a box plot, and finally compare different types of plot. So let's explore each part step by step. Now let's solve the part A for finding the mean and median. So for the mean, we simply add all the values and divide by the number of the students. When we add all these ratings together, we get 511. Now we divide 511 by 17 students, then we get 30.06. So the mean rating is 13.06. For the median is the middle value. Since we have 17 students, the formula of the position is n plus 1 divided by 2. That's 17 plus 1, which is 18. Divide by 2 equal 9. So the the ninth value is our sorted list. So we counted the left side. So first is 2, second is 13, third is 15, 16, and the fourth is 16, and the fifth is 16, and the sixth is 19, and the seventh is 20, and the eighth is 23, and the ninth is 27. So our median is 27. So here is the interesting observation. The mean is 13, so the mean is 30.06, which is higher than the median of 27. It tells us something. This tells us something is important. Our data is slightly right skewed, meaning it's pulled towards higher value. This makes sense because we have the outlier value of 70 pulling the mean upward. Now let's go the part number B. Now let's solve the part B and C. Find the mode at the mid-range. For part B, the mode. So mode is simply the value that appear most frequently looking at our data. We can see that the number 16 appear twice, but the other value appear only once. So the mode is 16. Commuting on modality. This data is more unimodal, meaning it is one clear peak or most frequent value. This tell us the most student rated the faculty measuring effectiveness around 16, which is the lower mid-range range of the scale. Now let's go the part C. So the part C, the mid-range. The mid-range formula is simple. We can take the minimum value and plus with the maximum value and divide by 2. So the minimum value is 2 and the maximum value is 17. And whenever we divide the values, then we get 72. Not 72, it's 36. So the most important note here, the mid-range is heavier influenced by extreme value. So in that case, we that outlier value of 70 is the polling mid-range, higher than where most of the our data actually lies. So now this all the about mode at the mid-range of that questions. According to that question we covered. So now let's go this solution and covered the solution part D and E part. So let's move parts D and E, calculating quotiles and the 5 number summary. For part D, quotiles divide our data into 4 equal parts. So first quotiles or Q1 represents the 25th percentile, and the position formula is n plus 1 divided by 4. That's 18 divided by 4, which equals 4.5. Since we get 4.5, we need to take the average of 4th and the 5th value in our sorted list are 16. So the average is 16. Therefore, Q1 equals 16. Third quotient or Q3 represents the 75th percentile. The position is 3 times n plus 1. Means it divided by 4, that's 3 times 18, which 24 divided by 4 equals 13.5. So we need the average of the 13th and the 14th value. The 13th value is 43 and the 14th value is 44. The average is equal to 43.5. Therefore, Q3 equals 43.5. So for part E, the 5th number summary, it consists of 5 key values. The first is minimum 2. First quotiles Q1 equal to 16 and the median is 27, and the third quotiles is equal to 43.5. So the maximum is 70. One more useful measure, the interquartiles range or IQR equal Q3 minus Q1, which is 43.5 minus 16 equals 27.5. This tells us the spread of the middle 50% of our data. Now let's tackle part F and G. creating a box plot and comparing different plots type. So for part F, the box plot, a box plot is a visual representation of our first number summary. Here how to read it. The box plot itself, the box itself is pen from Q1 to Q1 at 16 to Q3 at 44.3. Then inside the box we draw a line at the median, which is 27. Notice that this is the median line. So the median line is straightly to the forward left of the center of the line box, which again indicates our data is right skewed. The left skewed extends the box to be minimum value at 2. The right whisper extends all the way to our maximum value at 70. That long right whisper clearly show we have an outliner pulling our data towards higher value. For part G, comparing plots. This is the important conceptual question. A quantile plot or QQ plot compare our actual data quantile against a theoretical distributions. Usually the normal distribution, if the point fall on the straight line, it means our data follows the theoretical distribution. We use QQ plot to test assumption. So show the assumption which is required for many statistical tests. The quantile plot on the other hand, simply plot our data, our our ordered data value against their quantile position. It shows the actual shape of our distribution without comparing it to theoretical distribution. In the concept of student rating, a QQ plot would help to determine whether the faculty mentoring rating follow a normal distributions pattern, while a quantile plot would just show as how the rating are distributed across the scale. Let's move the question number 3, which deals with group data. The question asked us to compute the approximately median satisfaction score for the level interference. So we have a frequency distributions table and the scored range and the number of students in the each range. The range are 0 to 15 and the 16 to 30 and 21 to 50 and the 50 to 80 and 81 to 110. The frequency are 200, 450 and 300 and 300, 1500 and the 700 students respectively. The total is 13 to 50. So the step 1, calculate a communicative frequency. This means we keep adding frequencies as we move through the classes. At 15 200, at 20 200 plus 450 equals 650, at 50 650 plus 300 equals 950, at 80 950 plus 1500 equals 2450, at 110 2450 plus 700 equal to 3150. So the step number 2, in this step number, locate the median class. The median is an position n divided by 2. That's 3150 divided by 2, which equals 1575. Look for the communicative frequency across 15,575. So at the 950 we still below. At 2450 we crossed it. So the median class is 51 to 80 interval. So now let's go step number 3. So in this step number 3, apply the group data median formula. The formula is L plus in the bracket n over 20 minus CF previous divided by F times H. Let's explain the symbols. L is our 51, the lowest boundary of the median class, and our 2 is 150 1575. CF is a previous 950 communicative frequency, and before the median class F is 1500. The frequency of the median class H is 29. The class with 80 minus 51. Now let's calculate. And the calculation 1575 minus 950 equals 625. Divide 625 by 1500, multiply by 29, and we get 12.0308. So add this to the 51, and we get approximately 63. So the approximately median satisfaction score is 63 out of 110. This means half the students scored below 63 and half scored above 63. So this all about the question number 3. Finally, let's solve question number 4, which analyzes data from the lifelong learning departments. We have 18 students with the age and the productivity percentage. So now let's part A. So the part A asks us to calculate several statistics. For age, when we add all the 18 age, we get 846. Dividing by 18 gives us a mean age of 47 years. For median, since we have 18 students as a even, we take the average of the 9th and the 10th value when we sorted. Those value are 50 and the 52. So the median age is 51. The standard deviation. So the standard deviation which measure the spreads of age work out to approximately 13 years. This shows these quite a bit of age diversity in the group. For productivity, add all the productivity percentage give us 528.1%. And dividing by 18 gives us the mean productivity of 29.3%. So part B. So in the part B asked for the box plot for the both variables. So for the age, the box plot would show minimum at 23, Q1 around 22, median at 51, Q3 around 57, and maximum at 61. For productivity, the box plot would show minimum at 7.8%, Q1 around 26%, and the median at 30%, Q3 around 34%, and the maximum at 42.5%. For part C, the part C asked to create a scatter plot and Q to Q plot to study the relationship. The scatter plot of age versus productivity would show an interesting pattern. So this is the productivity correction. As age increase, productivity tends to increase as well. The strongest productivity appear in the 50 to 60 age range. The makes sense for the long time learning, where the experience and the maturity contribute to a better learning outcome. The Q1 plot Q to Q plot would help us to test whether either of these variable follow a normal distribution, which is important for validation any statistical test and might want to be performed on this data. So this all about the part C, relationship analysis. Okay. And that complete part A of our internal test. We have covered all 4 questions. So the question number 1 on the dispersion measures, and the question number 2 details with the descriptive statistics and the plot. Question number 3 on group data median calculation, and the question number 4 on relationship analysis between age and the productivity. I hope these explanations were clear and helpful. If you have any doubt and for any question, please leave them in the comment box, and don't forget like and subscribe for more data science video and tutorials. Thank you for watching.